Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the VCE 2025 physics examination. We will focus on questions related to the electric field. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. A. Correct. Both show inward-pointing arrows. Gravity is strictly attractive. The gravitational field direction is defined as the direction a test mass would move if placed in the field. Since any mass will be pulled toward the center of mass m, the field lines must point inward toward the object. The direction of an electric field is defined as the direction of the force exerted on a positive test charge. Because opposite charges attract, a positive test charge would be pulled toward a negative point charge, Q. Therefore, the electric field lines for a negative charge must also point inward. B. Incorrect. The charge Q shows outward arrows, which would be correct for a positive charge plus Q. C. Incorrect. Both show outward arrows. D. Incorrect. The mass m shows outward arrows, which is physically impossible for gravity. To find where the electric field is zero, we are looking for the null point, where the electric field from the plus q charge exactly cancels out the electric field from the plus 9q charge. Direction: between two positive charges, the electric fields point in opposite directions. The field from plus q pushes away to the right, and the field from plus 9q pushes away to the left. Magnitude: for the net field to be zero, the magnitudes must be equal. Use the formula for electric field and cancel out K and question A. Incorrect, because a null point always exists between two charges of the same sign. B and D. These distances don't satisfy the inverse square relationship. Since the second charge is 9 times stronger, the null point must be exactly sqrt 9 equals 3 times further from the plus 9q charge than it is from the plus q charge. Distance from plus q, 5 centimeters. Distance from plus 9q, 15 centimeters, which is 3 times 5. Total distance, 20 centimeters. The question requires only the magnitude of the electric field produced by charge A, rather than the vector sum of charges A and C. By applying the electric field formula and substituting the given values, the solution is obtained. We must now determine the net electric field at point D by calculating the vector sum of the fields from A and C. Since the positive sign, plus symbol, is conventionally omitted, we treat both charges as positive. Consequently, the field from A points south and the field from C points west. These combine into a resultant southwest vector, the magnitude of which is the hypotenuse of the right-angled triangle formed by the two fields. Electrons are emitted by a hot filament connected to a 12V battery. These electrons are accelerated between two metal plates, P and Q, which are 50 mm apart. The plates are connected to a battery, and the potential difference between them is 250 V. The experimental setup is shown in Figure 10. The entire apparatus is enclosed in a vacuum. It is important to distinguish that the electric force is produced by the 250V battery, not the 12V filament supply. Since the electric field remains constant between the plates, we calculate the force by first finding the electric field strength and then multiplying it by the electron's charge. Mark 1. The final kinetic energy remains unchanged because the work done on the electron depends solely on the potential difference. Mark 2. Since both the voltage, 250 V, and the electron's charge are constant, the energy gain is independent of the distance between the plates. 1. Field directions. Gravitational fields always point inward toward the mass, strictly attractive. Electric fields point inward for negative charges, Q, and outward for positive charges, plus Q. Visualizing fields. At point D in your square arrangement, the field from positive charge A points south, and the field from positive charge C points west. 2. Point charge calculations. Inverse square law, the field strength follows null points. Between two like charges, the electric field is zero where the opposing fields cancel out. 4 charges plus Q and plus 9Q separated by 20 centimeters. This null point occurs 5 centimeters from the smaller charge. Vector summation. To find the net field from multiple charges, you must treat them as vectors. For two identical perpendicular fields, the resultant magnitude is the hypotenuse and the direction is the diagonal, e.g., southwest. 3. Uniform electric fields, parallel plates. Field strength, calculated as the field is uniform, constant, between the plates. Electric force, the force on an electron is work and energy. The kinetic energy gained by an electron is equal to the work done. The distance rule. If the voltage, V, remains constant, changing the distance between the plates does not change the final kinetic energy. While the force and field strength change, the total work done stays the same. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.